So in this problem, we are rolling 2 fair dice. The first question says, what is the probability of rolling a double given that the sum was less than 7? Now, first of all, you need to notice this says given that, right? And the words given that implies that this is a conditional probability problem. So we want to know, what is the probability of rolling a double given that the sum was less than 7? I'm just going to write this in shorthand. Now, here's the thing you have to understand about what conditional probability is doing. At the end of the day, it is lowering your sample space. So whenever we roll 2 dice, we know that our sample space consists of 36 different possibilities. But we want to know, we are assuming that the sum was less than 7, which means if we go over to our chart here, we can actually cross off all of the ones whose sums are 7 or greater, because that's not part of the problem that we are talking about. So the assumption that the sum is less than 7 actually lowers our sample space. So this is the sample space now that we are talking about. And if we count them up, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. We have 15 in our denominator. That is our new sample space for this problem. And it wants to know the probability of rolling a double given we're in this particular sample space. Well, let's circle our doubles. We have 3 of them, and so the probability is just 1/5. Let's look at the next example. What is the probability of getting a sum of 7, let's see, given that the sum was greater than 4. So again, we're assuming the sum is greater than 4, which means that we can eliminate all of the possibilities where the sum is 4 or less. And we are actually reducing our sample space. We started with 36, but in this example, we reduce it by 6, meaning in this problem, we just have a sample space of 30. So now if we look at our chart and we say, okay, given the pieces that we're now talking about, which ones have a sum of 7? Well, that's this diagonal row here. There are 6 of them, and so essentially we just have 6 out of 30, which is 1/5 again. Again, just a fluke. Keep that in mind that this is the same as part A. Let's go to the last one. What is the probability that it's not a double given that the sum is a 12? Well, we are assuming in this problem that the sum is a 12. Well, the only one here whose sum is a 12 is a 6, which means that all of these are actually eliminated from our sample space, and I can cross them all off. So the sample space that we have here really consists of just one item, which is the 6 and the 6. So we've got one item here. But what is the probability that it's not a double? Well, that clearly is impossible, because the only way to roll a 12 is to roll a double. And so we've got 0/1 or 0, because it is impossible to not roll a double given rolling a 12.